All right, video lesson 9.4. Solving a log equation. So again, just to reiterate a couple important facts, things that we should know, or hopefully we know when dealing with logs. A couple important things that we mentioned the other day. Like for example, log base A of 1 is equal to 0. So it doesn't matter what the base is. If you take the log, it's going to be equal to 0. Some other things are log of a base of that number is always equal to 1. What's some other important ones here too? We mentioned the natural log of e is also equal to 1, and the natural log of 1 is 0. So those are important facts that we've talked about in previous video, but just want to reiterate them again. So when we're trying to solve these logs that we have here, the kind of general concept is the log base of a of, let's say, let's call it b, is equal to x. All right. So the terminology, I refer to it as under over, or a lot of teachers you may have heard in the past call it as whale it. So what happens is we can convert this to a exponential equation by taking the solution to the log equation, making it the exponent of the base and setting it equal to whatever the term that we're trying to take the log of. So like I said, if we do it as an under over, so I'm taking this out, I'm putting this one over, or if you refer to it as whale it, some people believe that it looks like a whale. So that would be equal, that would now make this a to the x is equal to b. So we can convert that and allow ourselves to now be in like a different format that I could actually solve, for the information. So let's take a couple examples and work through that process and see how we do. All right, so example 1. So again, I can do the whale it concept when I have a single log equal to a term, right? So like a number. So in this case here, I can now say I'm going to do this process, this under over process, or whale it. So I can rewrite this log equation into 2 to the 5th is equal to 5x plus 7. Once I have it in this format, we can definitely get a number here and allow us to actually solve this and find out what x is. So 2 raised to the 5th, that's what, 32. So I get 5x plus 7 is equal to 32. Let's subtract the 7 from both sides. That gets me 25 to equal 5x, which x would be then 5. So that allowed us to do that and solve for x. As always, or any equation really, I always recommend that you plug them back in, all right, and try and simplify and solve to see that it worked through a check. When dealing with a natural log, the same process occurs, but you have to remember that the base, right, of a natural log is e. So when I go to quote unquote whale it or under over, it's now going to be e to the 3rd power is equal to 4x minus 1. I could then solve for x in this scenario. So I'm leaving this in this term for the moment. So this is going to be e to the 3rd minus 1 is equal to 4x. Then I can divide everything by 4. So x is going to equal e to the 3rd minus 1 over 4. Now, when dealing with this, right, if I have this information and I actually plug that into the calculator, I could get an answer. E is a number. It's 2.71, blah, 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 blah. All right, it's a constant. It's a mathematical constant, just like pi is. So I could get an answer here. But again, unless it tells me to round, typically speaking, we just leave it in terms of e. Because like I said, it's just kind of like pi, where you're not going to get a nice whole number answer, typically speaking, so you're going to deal with it. Now, there are scenarios where e might drop out or simplify, so definitely want to check it. But we'll kind of look at those at a different time. So for right now, I'm going to say you're good here. If you did plug this into the calculator, overall, you would, let's see, if we plug this in here, we would get, let's say, here, e raised to the third power minus 1, and that answer was divided by 4, so that got us approximately 4.77, let's say, for example. So that would be, approximately 4.77, as we just said. All right, looking at example 3, you'll notice I do not have a single log equal to a number. So I have to condense this first. That's one of the reasons why we were talking about in the previous lesson, being able to condense and expand them. A lot of times we need to manipulate the equation in order to do so. So for here, right, I need to condense this first. So I have addition happening. So addition rule states that I can make it into 2 logs added together when the product of those terms is being taken. So I can now condense this to log base 4 of the product of these 2 terms, and that would still equal 3. So now, again, think of this as all as one giant thing in parentheses here. Now I can go and, under, over, or whale it, right? Under, over. So now I'm going to have an expression that says 4 to the third is equal to, and I can simplify this as just x squared minus 12x. Let's see, so if I simplify this process, 4 to the third is, 64? So 64, and I'm going to move it to the other side. So I'm going to minus the 64 to both sides. So that's going to get me, I'll just do it up here, x squared minus 12x minus 64 equals 0. I now have something that's factorable. Let's see, 64 factors would be 16 and 4 would work. So x minus 16, x plus 4. We can split this up. So I get x is 16, x to be negative 4. All right. One of the things you do need to be careful about, though, is we do need to check the values to make sure that it works. Specifically negative scenarios, because if I tried to plug this in right now, it's okay here. Actually, no, that also gives us a negative, but both of them give us a negative term that we have to take the log of. I can't do that. We'll go into that in a little bit more. I'll explain why, but we have to reject this term because I end up trying to take a log of a negative number, which I cannot do. So for this problem here, x equals 16 is my only solution for that one. All right. After we go through the examples, I'll get into a little bit more of a reason as to why that's the case. Just kind of give you an example as to why we can't have a negative if you're not sure, but we'll do that at the end. All right, let's do another one here. So we can condense this. Again, subtraction here tells me that I can divide the terms. Be careful here because order does matter. This first one has to be the numerator. The second one has to be the denominator. So I'm going to have log of x over 5 is equal to 6. So when I go to, whale this one, right, under, over, what's the base here? I don't have anything written. Again, remember, if it's not written, by default, it's 10. So that makes this become 10 to the 6th equals x over 5. For something like this, I would put this over 1, cross multiply. So I really have x is equal to 5 times 10 to the 6th. What is that going to be? 1,000,000? Right? So therefore, x is really 5 million. And that would be my value for that. Again, plugging it in, check, see that it worked out. All right, example number 5 here. Let's look at this one here. So once again, I want to condense, right? This process. Now on the sheet, actually, I forgot, I changed this on your sheet. I believe I did. If I didn't, let's do it now. I wanted to make that a 2. So when I have a number on the outside, don't forget the power rule says that I could power down the log by making it a multiplier on the outside. So if I'm condensing this, I now have to change that. I got to make this the exponent of that, right? And then I can condense this. So I really am going to have here a situation that says log base 3 of x squared, and again, it's the product, so it's times 1. So again, this is all one thing, equal to 4. So again, if I go to do my process here and I whale it, I'm going to have 3 to the 4th is equal to, well, that's just x squared. 3 to the 4th is 81, so that's x squared. So x is going to equal, now I would normally say take the square root, right, of both sides. So I would say that the solution would be x is plus or minus 2. But again, here, notice in this scenario, if I plugged in a negative, right, I would be taking the log of a negative number. So I can't have that part. So therefore, x only equals 2, right? X cannot equal negative 2 in this case. All right, so this is my solution. Now, why is that? All right, we have to kind of think back for a second, think of the information and the concepts of what happens when you're dealing with these. So let's just take an example. Since we have a base of 3, let's use that one. So let's try just saying log base 3 of 0, right? What would that be? Well, let's set that equal to x so that we have an equation, right? Well, if I did that and I went to do my whole rule, right, and I powered it up, so this would get us 3 to the x is equal to 0. Well, when is any base number, right, equal to 0, right? If I take that number, this exponent, right, from here, is it possible, right? Every time I do this, x is going to be a positive number, right? So there's no solution here, right? If I was to take this, x in this scenario is going to be, to get that, I'm not going to have anything I can raise this to get 0 from there. So that's the scenario that happens. I can't get this situation. So same thing happens when I'm dealing with this exponent possibility. I'm not going to get that negative, or in this case, equal to 0. So thus, in this case, DNE does not exist, right? So that is why we cannot take the log of a negative number. So it's important to know that. That'll help you in the process of solving these things, so that you can kind of help. Some other key things is, if you look here back in example number 5, I could have actually solved this and simplified this a little bit easier, because again, log base 3 of 1, if we kind of go back up top, right, and say when is that, it would be 0, right? Log of any base of 1 is 0. So I could have said and dropped this part out and just had a single 1 and had to kind of eliminate part of my process, if you notice that. If you didn't, it's fine. Obviously, it worked out. But those are the kinds of things that sometimes you can make yourselves a little bit easier. If you know the rules and you know the facts, it definitely will be easier in terms of simplifying the expressions or the process. One other thing, and I'll just do this real quick because the video is getting a little long, but if you have a scenario with an equation, and we're going to talk more about this, but just as a brief intro to it, if I have, let's say log base 2 of x is equal to log base 2 of, let's say, 5. As long as I have two logs that are equal to each other, if I have a log equal to a log, if they have the same bases, I can actually drop the logs and just set the two terms equal to each other. So in this case, x would be 5, right? Look at it in a slightly more complex version. So if I said to you here, log base 3 of 4 is equal to log base 3 of, let's say, x plus 5, right? Once again, as long as these bases are the same and I have a single log equal to a single log, if that's true, then I can drop these. We can set the terms equal to each other, right? And then we can go and solve here. So if I was to solve this, minus the 5 from both sides, x is -1 in this case for that to work out. So that's another example of how we can utilize log equations when they have these logs on both sides. Again, in a lot of cases, sometimes just adding or subtracting the log over might make it easier, because then we can condense them or something like that. It kind of depends on the situation. We'll look into a little bit more details with those as we move forward in the unit, but it is just a good thing to have there as well. So, all right, take the opportunity to get these notes down, review some of the problems if you have trouble with them. Go back and relook at the video. I've also given you guys practice problems for you guys to try.